R44 Safety Notice Quiz. During takeoff, what effect will an overspeed have on the helicopter? Throughout normal RPM range, the tail rotor vibration is controlled by a damper bearing. However, the damper bearing is not effective above 120% RPM. Tail rotor RPMs above 120% will cause vibrations that can cause failure to the tail cone and the drive shaft, which may lead to immediate failure of the shaft and the tail cone. During liftoff, what might cause an overspeed? If the RPM is increased to normal operational settings, mechanical correlation can cause an overspeed during liftoff if throttle is increased to normal flight settings and the collective is raised before the governor is switched on. If a pilot exceeds the power or airspeed limits and no change is noticeable, might there be any consequences? Every second limitations are exceeded, more stress cycles occur, and additional fatigue damage can occur within the metal. When might the most damaging conditions occur? The most damaging conditions occur when flying at high airspeeds and high power settings. Every time that the limitation is exceeded, a small crack can grow to the point of fracture and go unnoticed. If a rotor was just balanced, and then within a few flights goes out of balancing again, what might have caused it? The rotor blade may have an external or internal crack even if it's not noticed, and will likely cause a significant rotor vibration prior to final failure. While flying, you notice a strong, rapidly increasing, low-frequency vibration. What might be the cause? If rotor vibration rapidly increases, there might be a crack and you should land immediately without going to a convenient destination. During takeoff, while in a hover, the pilot notices one of the doors is unlocked and unlatched. What should the pilot do about it? The pilot should land and close the door, then take off again. Prior to takeoff, while in a hover, the pilot notices the radio is not set to the correct frequency. What should the pilot do about it? The pilot should land before changing frequencies, then pick up into hover again. While doing the pre-flight inspection, the pilot reads the journey log and notices that the aircraft just came out of maintenance. Once noticing this, should the pilot do anything differently? Yes, the pilot should do a more thorough pre-flight inspection just in case any of the parts were not assembled correctly or thoroughly. Sometimes a tool might be left behind as well. If it's not written in the journey log, the pilot should talk to the maintenance personnel and find out what specifically was done so that they can give a more detailed inspection to those areas. This is especially the case with flight control systems. Can the aircraft fly with luggage or cargo stowed on the landing skids? No, the landing gear are not designed to take downward weight. They're only meant to take upward weight, even for hard landings. An object stowed on the landing skids might cause vibration that could cause damage to the airframe. During a descent, what might happen if the pilot pushes the cyclic far forward? By pushing the cyclic far forward during a rapid descent, the pilot might create a low G situation or even a mast bumping situation. Instead, the pilot should lower the collective to descend and give a slight forward movement on the cyclic. Above 3,000 feet, should anything be done differently while controlling the power settings? Yes, it may be necessary to roll the throttle off while lowering the collective to prevent an overspeed. Which part of the rotor system prevents the rotors from drooping during a shutdown procedure, and possibly even hitting the tail cone? The droop stop friction. If the engine is running rough and the pilot suspects a magneto failure, what might happen if the magnetos are checked during flight? If only one magneto is working and the pilot grounds the other one, the engine might stop completely. Leave the magneto in the both position and land as soon as practical. A helicopter is lightly loaded with one passenger in the front seat. Takeoff is smooth, but near the end of the flight, the helicopter starts producing a forward-aft oscillation. What might be causing this? The center of gravity has shifted forward. How does a pilot stop that oscillation? Return to straight and level powered flight. It may take a few seconds for the oscillation to dissipate. While flying with low RPM, what might pushing the cyclic forward do? A forward cyclic will lower the nose, but it will also lower the RPM of the rotor. If the RPM drops too much, it is not recoverable. What might cause the helicopter to continue pitching forward after inputting aft cyclic? A possible low G situation, where the rotor tilts aft before being reloaded. What might cause a powerful right roll in a low G situation? The rotor torque reaction plus the tail rotor creates a right rolling moment. While in a low G situation, the helicopter suddenly rolls right. Left cyclic does nothing to correct this. If the pilot continues to move the cyclic left, what might happen? Mast bumping might occur. What might severe mast bumping cause? Severe mast bumping might cause the main rotor shaft separation and the rotor blade to make contact with the fuselage. If a low G situation is suspected, what should the pilot do? The pilot needs to reload the rotor disc before lateral cyclic will be effective. The way to do this is to apply immediate, gentle aft cyclic and avoid large aft cyclic inputs. Why should the pilot never leave the helicopter unattended while running? The collective can creep up, increasing both pitch and throttle, causing the helicopter to lift off or even roll. What would happen to a helicopter if it stalled while above translational lift? The forward movement of the helicopter will create a higher amount of airflow on the advancing blade than on the retreating blade. This will cause the retreating blade to dive as it goes aft while the advancing blade climbs as it moves forward. The resulting low aft blade and high forward blade is called rotor blowback. As the helicopter begins to fall, the upward flow under the tail surfaces tends to tilt the nose of the aircraft down. The pilot will usually apply aft cyclic to try to correct this. These two effects plus the pilot's input will frequently cause the rotors to chop off the tail boom, which is called blowback, as the helicopter is falling. While in a hover, what should be done to recover from a low engine RPM setting? Lower the collective and increase the throttle. While in forward flight, what should be done to recover from a low engine RPM setting? Lower the collective and increase the throttle with a slight aft cyclic. While flying, the pilot hears a whine, rumble, or siren sound. What might be the cause? That's the sound of an impending bearing failure. Teletemps might not actually read those failures until disintegration starts. What should the pilot do if they suspect an impending bearing failure? Land immediately. What might cause a clutch light to flicker? It might be caused by a belt or bearing failure. What should be done if the clutch light is flickering? The clutch circuit breaker should be pulled and the pilot should reduce power. Then the pilot should make a precautionary landing. If noise, the smell of hot rubber, the tack needle splits, or vibration are present, land immediately. What should the pilot do if the aircraft just came out of maintenance after having its belt drive system worked on? They should verify a maximum of 1.5-inch deflection before flight. While running up, verify that the rotor turns within 5 seconds after engaging the clutch switch. If the belts seem to be tight, the pilot might want to leave the belts tensioned after the flight. Then after the battery switch is shut off, disengage the clutch. This will allow the belts to loosen slightly. Before the next flight, disengage the clutch to release tension on the belts before starting the engine. What will happen if the clutch switch is left on for a long period of time while the battery is off? The tachometer will slowly drain the battery. During a low-speed flight, the pilot loses translational lift and begins to settle. What should they do? The pilot should lower the collective and increase the throttle. Once the engine is above 90%, a slight forward cyclic may increase the speed. If the pilot applies forward cyclic before reaching 90% RPM, they may lower the RPM to a point of stall. An inexperienced pilot may raise the collective to try to stop the descent. This can reduce the RPM, thus reducing the power available, and cause an even greater rate of descent and further loss of RPM. Rolling on the throttle will increase the rotor torque, but not the rotor RPM due to the low power available. Because the tail rotor is proportional to the square of the rotor RPM, if the main rotor drops below 80%, nearly half of the tail rotor thrust is lost, and the helicopter will rotate nose right. When not doing emergency training, is there any time that might be appropriate to turn off the governor? Only when flying near high-power towers that are 50 kilowatts or greater. What might a high-power tower do to the governor? The electromagnetic interference may cause the governor to overspeed or lower the RPM. What might a high-power tower over 50 kilowatts do to a helicopter? Erratic engine governor and tachometer operation. The warning lights might randomly illuminate. In extreme cases, the governor may attempt to fully open or fully close the throttle. What distance should the pilot keep from a high-power broadcast tower? The pilot should keep at least a half-mile distance. What can cause an overspeed during liftoff? Gripping the throttle too firmly or not turning on the governor. What might abrupt control inputs or accelerated maneuvers do to the helicopter at high speed? They may produce high fatigue loads and over time could lead to failure of a critical component. Can pulling the collective to slow the rotors during shutdown help to speed up the process? Collective pitch provides lift on the blades, which can disengage the droop stop friction and allow the blades to strike the tail cone. Is long, dry grass a suitable landing spot for a helicopter? The exhaust might light a grass fire. What is the most effective way to stop dynamic rollover? Quickly apply the down collective. If the rotor RPM drops by 10%, there is how much less power? %. What reflex should be conditioned for low RPM warnings? Simultaneously roll on the throttle and lower the collective. What might happen after pushing the cyclic forward from level flight? A low G pushover, which is detectable by a right rolling moment on the fuselage, and must be countered by slowly raising the collective before applying left cyclic. During takeoff, you notice a pole ahead of you, but see no wires. What should you do? Fly directly over the pole. What should the pilot do when passengers are boarding a running helicopter? The pilot should firmly grip the controls in case a passenger bumps them. Why is it dangerous to fly over water? Many pilots lose their depth perception and misjudge their height above the water. During a downwind landing, the pilot experiences slight increased vibration levels and a rapid increase in sink rate. What might the cause be? Vortex ring state. However, mushy controls are a more predominant sign. Should passengers ever approach the helicopter from behind? No, walking into the tail rotor can be fatal, along with exhaust fumes. Why should fuel caps be checked before starting the engine? Because loose objects can be fatal. Any object striking the tail rotor can cause failure of the tail rotor blade. In worst cases, damage to the tail rotor may cause a severe out of balance condition that can separate the tail rotor gearbox or the entire tail assembly from the tail cone, resulting in a catastrophic accident. Should passengers be allowed to stick their phones out the window to take pictures? No, loose objects can hit the tail rotor. While at cruise speed, the pilot encounters severe turbulence. What should they do? Reduce power to 60 to 70 knots. If the RPM decreases to 80%, how much power is lost from the tail rotor? Nearly 1/2 of the tail rotor thrust. What may cause unanticipated yaw? A left crosswind.